So this is the final result. When you move the light into any distance from the object, the light constantly adjusts the exposure automatically with respect to the distance so that we get the same intensity on the object. Hey, what's up guys? Welcome back to Swats Tuts. Today I'm going to show you magic inside Maya. In most of the lighting scenarios where you use software lights except HDRI, you may have faced this situation where you place a light at a particular position, adjust its intensity, then for some reason or you had to move the light to some other location for better lighting or to get a better dimension on the subject, but you like the intensity of the former position, and now you have to adjust the intensity again to match it with the previous one. And this is a common situation in every lighting scenarios, whether it's a character, an object, or a scene. And most of the time it will be a long process adjusting the exposure with each position, and this is a headache, right? So what if I tell you you can remove that headache with a simple magic spell? So instead of saying the spell, we have to type it inside Maya. You can call them expressions, and this is what the results look like. So with the normal light, what happens is if you move the light on the scene, when it comes closer to the object, the scene gets brighter and the object gets brighter, and if it moves away from the subject gets darker. So this is a normal scenario, everyone knows it, but what I'm going to show here is another different kind of light where if we move the light closer or away from the light, if you see the object's brightness, it remains the same on a particular point. If you look at the head of the tiger, you can see even if it's away and coming closer, the light intensity on it remained the same. So you can also adjust the light as you wish. If you feel it, the light intensity is brighter, you can reduce it, and if again you move it, it conserves the same amount of light by adjusting the intensity according to the distance of the light from the subject. And also if you look at the shadows, you can see when the light goes further from the object, the shadow softness is very hard, and if the light comes closer to the object, the shadow softness is edge of the shadow is very soft. And if you see this light that I have created, if you look closely to this light, you can see with distance the area of that particular light is increasing, and as a result, if you look at the shadows, so if you look at this shadow, if I increase the light's distance from the subject, you can see slightly moves its position, but the shadow softness remains almost close to the previous one. So it can be always really accurate to the previous shadow, because when the light moves away from this object and it gets bigger, there is a chance that a lot of indirect bounces is casted onto the shadows and it gets a little bit softer than before when it goes further away from the subject. But considering the previous situation where if I hide this and bring back our previous light, if you notice here, you can see how much the shadow softness is changing. But in our case, the second light, the change is not that much. It remains almost closer to the previous one. So these are the two expressions which are going to discuss in this tutorial. Although I'm using the Maya software for the demonstration, I'll tell you the techniques that you can use to make it work in other softwares too. And even if you have no previous experience with this expression, or even if you are not good with maths, that's totally fine. You can make it work just by copy pasting. It's simple. Before going into the practical session, let's have a quick theory behind this magic. You all know that the light has a decay or fall off, right? That is, with increase in distance, the intensity of the light reduces. And in Maya, if you check the default lights, you can see there are a few types of decay rates available in the lights, mostly in point light, spotlight, and the Maya area light. It will not be available for the directional light because directional light has no point of origin. And the decay rate that matches with the real world lighting is quadratic decay, which is now the default or the only decay which is available inside many PBR render engines like Arnold, V-Ray, or Internet. The quadratic decay obeys the inverse square law. This is a law which is also obeyed by the real world lights. And the law states that the intensity of any light is inversely proportional to the square of the distance from the light to the subject. So if the intensity is represented with the letter I and the distance is represented with the letter D, then we can write the equation as I is proportional to 1 by d square, which means when the distance from the light to the subject increases, the intensity decreases. And from this equation, we can also write another equation that I by d square is a constant. What that means is, if with increasing the distance from light to the subject, or if the light is moving away from the subject, if we are also able to increase the light intensity proportionately, then we will always be getting a constant value when we divide the intensity with the square of the distance. So because both of them are increasing proportionally, so the value we get by dividing the intensity with the square of the distance will be always the same value. So let's consider a situation where the constant value we are getting is 1. Then our equation gets simplified to intensity is equal to square of the distance. And this is the equation what we are going to apply in our lights through expression. So let's see how we set up the light in Maya software. So we have a basic setup here with a 3D model, a camera, and a plane. So this is a 3D scan which I have downloaded from 3dscans.com. I've put the link in the description. You can check that out. You can get a lot of 3D scan models for free. Make sure you check that out. And now the first thing we are going to do here is create a locator for our object. So the reason I'm using a locator here is to point from where we can calculate the distance to the light. So just make sure that when you placing the locator, it's not inside the subject, it's always on the surface. So you can use a snapping function for this so that it's always on a particular position. And then again, the second thing is So let's name it as object locator main. This will be our main locator for positioning to our subject. And now let's create a light. So for this tutorial I'm going to use Arnold area light, and I'm going to scale it to a value of 10. Now the first thing I'm going to do here is I'm going to aim constrain the light to this locator, so that when I move the light on the scene, it will always orient its face onto this locator, so that we don't have to move the light then again rotate it to this object every time we move the light around the scene. So to do that, first what I'm going to do is I'm going to align its X and Y axis with the locator. So for this I'm going to first select the light, then the locator, and then click on the translate text and just press tab. So now it got aligned with the locator. Now I'm going to constrain it by selecting the locator first, then the light, and going to the animation constraint menu, aim constraint, going into its option. So I'm going to just resetting the settings, and you don't have to change anything. We are going to constrain all the axes with the locator, and make sure to check this maintain offset box on, because if you don't, the light will go to the locator's position. That we don't want that. And let's click add. So if you see the outliner, there is a constraint on the light, and now if you move the light anywhere in the scene, you can see the light is facing the locator if we move anywhere. So our constraint is set, and the second thing now we are going to create is a distance dimension tool. So for this I'm going to go to create, go to measure tools, click on distance tool, and then just click on anywhere on the viewport to create the distance dimension. This is what we are going to use to calculate the distance between this locator to the light. So for this we have to place one of the distance dimension locator on our main locator, and the second one onto the light. So for this I'm going to use the same method, and I'm adding the locator under our main locator, so it gets parented to our main locator. So when we move the locator, the distance gets calculated. And you can also see when we move the locator, our light also aims the locator. And now the second locator is going to be positioned with the light, and I'm adding it inside the light. So now the distance dimension, the distance value we get here becomes the distance value from the light to our subject, and this is the value what we are going to use as the D, or the distance from the light to the subject, in our expression. So now in order to add the expression, first you have to copy the distance dimension shape name here. Make sure you are copying the shape name, not the transform name, because the attribute we are going to use for the expression is this distance attribute, and it's the attribute of the shape node, not the transform node. So I'm copying the distance dimension shape to name here, and going to the light. Now to add an expression to the intensity, right click on the intensity name, and then click on creating expression, and you can see the object and the selected attribute is highlighted here. So I'm just selecting the attribute and middle mouse click and dragging it into the expression panel, and I'm adding expression as the AI area light shape 1 intensity is equal to I'm pasting the distance dimension shape to name, then I'm adding a dot and I am writing the attribute name which I'm going to use in the expression. And now let's just click on create. So if you see now, the distance dimension value here 61.725 is got added onto the intensity. So if I move the light now, this value automatically is loaded onto the intensity with our expression. So but our expression is not still completed, because it's not just the distance value that we want, it's the square of the distance. So we are going back to the expression by right clicking and going to edit expression. Now we have to do the square of this value. So you can do this in two ways. Either you can just simply add a multiplication and copy pasting this same attribute again, so it gives us the square of this particular value. Or if you are pretty experienced in the expression and scripting, you can use a power function which comes as POW, then the base value of the power function, and then the exponent value, which is in our case is square, which is 2. So if we click on edit, now if you see, the value has not changed because the method is different but the result is same. So if you're not good with expression and things, you can just use simple multiplication, like adding an asterisk, then again copy pasting the same value. So both of them works the same way. So let's check it out, the render, how the light is coming now. So the benefit of this here is you have two attributes to control the light intensity in lights. One is intensity and exposure. So once the expression is added onto an attribute, we can't change the attribute values on that particular attribute again. So if you decide that we want more intensity onto the light, you can always change the exposure value, which will change the light. And again, if we now move the light, you can see the intensity is remaining constant on that particular point. And now if you want to change that particular point, let's say you don't want the intensity to be constant around this part, you want it to be constant around the snake. So we just have to move the light locator, our object locator, onto the snake, so that the intensity will be constant on that part, and with respect to that, other parts will have a slight variation in intensity. So this is how we add the intensity expression onto the intensity attribute. And now let's look at how we can add the same attribute on the exposure, because some of the artists prefer to adjust the intensity, and some of them prefer to adjust the intensity in the exposure. So if you are someone who doesn't understand how the exposure works, or you prefer to adjust the light values on the intensity attribute, you can add the expression on the intensity, the exposure attribute, and prefer to change the intensity on the intensity attribute. So for that, let's delete this expression by right clicking and click on delete. So and let's put the light back to its default, and let's create the expression on the exposure. So now, as you know, the exposure and intensity works different. One is a linear value and the exposure is an exponent value. If the exposure is 10, then the equal value of exposure 10 in the intensity will be 1024, because that's the value we get when we raise the 2 to the power of 10. So that's how the exposure works. So in order to get the same attribute or expression work for the exposure, we have to use a logarithm. So the expression changes to log of distance dimension shape 2, and here again this is not just distance dimension shape, we have to do the square, which means we also have to use the power function, or you can use the multiplication. And the thing about the logarithm is, by default the logarithm value uses the base of 10, but in here the exposure function works in the power of 2, so we have to use the logarithm to the base value of 2. So to get logarithm to the base value of 2, the simple function is, if you want to find the log of a value a to the base of a value b, then the common function is log of a divided by log of b. Here we have to find the value of the square of this distance value to the base of 2, so we have to first put the log of square of this distance divided by the log of 2. So this is how the expression in the exposure works, and if you don't want this to be this much longer, you can also use a power function inside it. So it comes to power. So let's check if the expression is right or not. So now we are adjusting the intensity on the intensity attribute. Now if we check the expression, or by moving the light again on the scene, you can see that on that particular subject the light is still remaining constant. So that's how you add expression onto the light intensity or the exposure. So you can prefer either way, both ways works totally fine. And the only thing is, you have to have a basic understanding of how this expression works. If you don't understand any of these logarithm things or any of these things, the only thing that's going to change on these expressions is this distance dimension shape, because if we are changing the name here, or here we get the name as distance dimension 2, but when we are creating it for the first time, it comes in the name distance dimension 1. So you can see this is the only name that is going to change. So if the name, according to that name, you have to just copy paste the name in here. So that's the only thing that we have to do here. The rest of the things are same for all the attributes, and I have also put a sample Maya scene file on the description, so you can download it and check it out if you are struggling with creating expressions. If you're having trouble to understand or creating this effect through expression, then you can simply do this through nodes. So I'll just show you how to do this by nodes with Arnold nodes and also with default Maya nodes. So I'm sure that the nodes will be available in other softwares too, so you can find some nodes which are available on any particular software and you can work with that. So for this, first I'm going to add this distance dimension onto the node editor by selecting the shape and just clicking this plus button. So in here what we need is the shape node, we don't want this one, the transform one. So what we usually do as expression is do the exponential or power function of this distance value, right? So if you expand this, and you can see there is a distance value right here. You can see this. If you are not able to find this, you can always type here distance and you can find it. And now we are going to create an Arnold node called AI power, AI POW. So here you can see a base attribute and an exponent attribute. So the base is what our distance will go into, and the exponent is what we use as the exponent value, which we usually do is 2. So I'm going to expand this by clicking this button and we can get the base value here. So I'm just going to add the distance value into the base R, G and blue channels. Now for exponent, we are just going into the value and just going to type 2. So we have just given the expression through the node itself, and now we are going to add the light into the node graph. So if we add this into the intensity value, you can see the intensity becomes 0 because our node by default may not be taking this value as an attribute value into the intensity. So what we can do in this situation is we can try to add this into our color. So in that way, let's see if that is working or not. If you see again the head part, the equation or the formula is also working with these nodes, and the only thing is we can't put any textures back into this node because we have put the node already put some nodes into this. So if we want to put any color texture into the nodes, maybe some black body or something, then we'll have to use an AI composite node again and just blend this using any modes, and can then put the composite node into the color. So that way you can get the color also. If you want to add some texture, you can also add some texture into it, and you can add texture onto the file, and then again the equation also works with this technique. And let's say if you are not using Arnold, then you can use a multiply node, multiply divide, and connect this distance into input 1 and 2. So that it's, and use the operation multiply so that the same values will multiply, which is equal to the exponent value of 2, and we can add the output into the composite or straight into the color. Now you can see we get the same output with that node also. So you can prefer this method also if the expressions are not working for you. Now let's check out how we can also make the shadows constant. So for this one, I'm going to make the length and width a little bit different for light. And so for our next expression, let's look at this particular shadow. If you see, I'm just saving it and I'm moving the light closer. So if you compare this one to this one, you can see the shadow is moving, that's okay, but look at the edge of the shadow. When the light moves closer to the subject, for the subject, the light is getting bigger. As a result, the light increases the softness of the shadows. And it also changes the contrast of the scene, because with hard shadows and soft shadows, the contrast of the scene changes. So it gets, if it moves further away from the subject, the effective size of the light according to the scene is smaller, and that makes the light a hard light, which creates a hard shadows. So if we want to move around the light in the scene, and at the same time we don't want to change the shadow softness or contrast of the scene, then you can use another expression on the scale of the light, so that when this light moves away or closer to the subject, according to its distance, the scale also changes with it. For this thing to work, first you have to place a light in a certain position, and you just have to copy a certain scale and distance values from that current position to create the expression first. So I'm just randomly placing it on a position, and now I'm going to create an expression on the both scale x and y. So I'm adding an expression on the scale x first. So what I'm adding here is I'm again using the same attribute, distance, dimension, distance. So the thing is, if a light moves further away, or the distance from the light to the subject gets doubled, the light's area of the light should also get doubled, so that it gives the same amount of softness in the shadows. So currently we have the same the distance, dimension, shape, this attribute value, and I'm adding the same value of 45.404 here. So when this current value divided by this value, we get a value of 1, and then we will multiply this with our current scale, which is 5. So when we create this expression, okay, we didn't copy the shape now. Okay, now the scale is still not changed, because this value is currently equal to exactly this value. So dividing this by this gives us 1, multiplied by 5 gives us 5. So the same thing we are going to use on the scale y also. So changing the scale x to scale y, and here we are going to multiply with the current scale of y, which is 2. So now if we move the light, we can see the light scale changes with distance. So if we have a square light, which was our first thing, our light was a square light, we don't have to do this thing. We just need, if x and y are the same, then you can put scale y is equal to scale x, so that it will automatically copy this expression to scale y also. And this is the case where I have purposefully added a different value on x and y, because I wanted to show you how if the scale values are different, because that is a lengthy expression, right? On the second one, you don't have to put this expression here, you just have to put scale y is equal to scale x. So that's how the square lights works. Now our expression is ready. Let's check it on the render, how the shadow is behaving with our new light. So you can see this was what happened before when we moved the light closer, and now let's see what happens now if we move the light closer to the subject. You can see even the shadow moves towards the front, but if you check the light softness, it's almost closer to the previous one. Only the position of the shadow changes with the light position. That's going to happen, but even from this distance, it kind of gives the same softness to the shadow edges, which is pretty cool. And so that's the two expressions which is going to make our life so much easier when we are lighting a scene or a subject or anything on the software. This is something which I am also going to use when I am going to make my look development rig with software lights. So this is the simple process that you can do with expressions to make the lights get a constant exposure with moving and to get a constant softness on the shadows. So now we have seen how to create the constant exposure light with constant shadow contrast in the Maya software, and let's see how we can replicate the same method in other softwares. So if we go into any other software, for example 3S Max or C4D or Houdini, well, in the case of Houdini, from Houdini 18, they have this feature inside Houdini. I have seen some feature videos which shows this method on Houdini, so we don't have to worry about Houdini, it's already there. But with other softwares, if you see, there will be a render engine for other softwares, so and they will have some area lights or any other lights, and there will be our asset which we need to light, and also they might have something for scripting or adding expressions. It's all compulsory, or it's all will be definitely going to be there in any software. The thing which we need is a method to calculate the distance from any particular point on the subject to the light. So a simple method I'm going to show you here is, if you go to the distance tool again, distance dimension tool again, the value which gets calculated here is calculated with a formula, a mathematical formula, which it just uses the formula to calculate the distance between 2 points in the 3D space. So in the mathematical language, we can say if this point in 3D space is point A and this one here is point B, then the point A has a coordinate or translate values of x1, y1 and z1, and then point B has a translate value of x2, y2 and z2. Then the distance between 2 points are calculated with the equation like if the distance d is equal to the square root of x2 minus x1 all square plus y2 minus y1 all square plus z2 minus z1 all square. This is the equation which is applied on the distance dimension here. So you can use the same equation to get the same output on any software if you know how to work or write the expressions on that particular software or write the scripts. So I'm going to show you in Maya how we can calculate the distance between them and apply the formula onto the light intensity without using the distance dimension. So for this I'm going to just use a sphere here, and so we can scale it down if you want, or you can make it non-renderable. You can maybe you want to leave it as a bounding box so that it won't get rendered in with the object, and now you can place it anywhere on the object. So this will act as our locator here, and now we can maybe even you can constrain the light to the sphere so it moves oriented to the sphere, and now you can use the translate values of sphere and the light to create the expression. So let's see how we can create the expression on the light. So if you come here, let's put the spheres, let's copy this spheres translate x value for now, and just let's add it in here as a starting point. Let's see. Okay, now if we are to use these translate x for sphere and the area light shape 1, then usually the thing is, with these lengthy names, the expression is going to be very lengthy expression, and because of those length there's possibility that some brackets and commas going to be misplaced. So in this case we are going to shorten this expression with some strings. So the use of strings is, if we have a name here, if we are using a string like $a, and we are saying $a, this string has the value p_1 x. Then if we put here the $a, then after editing the expression, Maya is going to check the string value in the expression, and if it finds an object's value which is given to this string, then it is going to apply this value here on wherever we have put the particular string value. So by this thing we can shorten the expression's length so that it gets easier for us to understand and try to minimize these errors which can occur when we are using this kind of lengthy names. So I'm going to add another string also for the translate y and z. I'm also going to add translate values for the light translations also. So I'm quickly going to add. So you can give any name in the string here. You can say x1 or x2, just like the equation, and also you can add names like sphere. I'm just preferring to add simple names like $a, b, and c. So our strings are now complete, and now we can try adding these strings onto our expression. So in here, when you add x2 minus x1 or y2 minus y1, it doesn't matter which value comes first. Either you can put the spheres translate x as x1 or the light shape as x1. It doesn't matter. The only thing you have to look out for is, if you use this spheres translate x as x1, then make sure you use the spheres translate y and z as y1 and z1, not the area light shapes. That's the only thing you have to consider when adding this equation onto it. So I am taking the sphere 1 translate x as x2 here. So I am completing the equation, and now x2 minus x1. So if x2 is $a, then x1 becomes $d. So I'm adding $d here. So if we edit again, okay, again, when we are using translate, it doesn't come in the shape node, it comes on the transform node. So make sure you don't use shape on the expression. So I'm deleting the shapes from there. Let's see now. Now when we are using the dollar, the string values, we get the value 0 because we are using the translate x values here. So if you check the translate x of sphere, it's 12.981, and also area light has the same value because it has the same position in the x axis. So let's change it a bit so that we get some values here. So if we check again, so now if you see, it's still giving this 0 value because that's because the intensity doesn't go into negative values. So we have given $a minus $d. $a is spheres translate x, which is giving us value 12.981, and the area light transformation is bigger than that value. So when it is the spheres transform x gets minused from this value, it goes into minus value, which we can't add into the intensity. So that's why it's still giving this error. But now we just don't need this value. We have to do the power function here. We have to square this according to the equations. So I'm adding a power function here, comma 2. Now if we edit this, we get some values here. So this is just the translate x on the equation x2 minus x1 all square. This is just x2 minus x1 all square, and so the equation is on the square root of x2 minus x1, etc., right? And when we use the, if you remember our old equation, it's I intensity is equal to d square, which is square of the distance. So when we use the square root with the square root and the square gets cancelled to each other, and we are only left with the equation x2 minus x1 all square plus y2 minus y1 all square plus z2 minus z1 all square. So we don't have to add any power function after this, just like we did before on the intensity equation. And now we can just continue with the script by changing. I'm just copy pasting the x values, and I am going to just change the string values here. So right now, if you see, the A string is replaced by the B, not the E string, because that's what I just said before. Like sphere 1 translate x is considered to be x2, then translate y should be considered on the second y as y2, not the E. And now the last one is Z. It's C and F. So if we edit, let's check if our value is working or not. So we have put the sphere on here, so it's still visible on the render. Okay, now it won't render. So let's try moving the light on the scene. You can see we have put the light on the head shape. If you see the head, you can see the equation still works with our new formula. So it's the same method. You can replicate this method to any software. You just have to use this simple mathematical equation to find the distance between two different points, and you can put that you can use that equation to create expression or script onto the intensity, and that's it. You are done with the equation. And you can simply use the scale script as it is on any other software, because it's the same thing. Once we get the distance function, that the second thing becomes really easy. You don't have to create any other or create any more scripts or any things. So this is it. So I hope you liked the video and the things I have shown you, and I hope you learned something. So if you really liked it, give a thumbs up, and if you have any more doubts on this thing, just put it on the comment box and I'll definitely gonna reply. Make sure you subscribe to this channel for more future contents like this, and definitely share it with your friends who are really interested into clip development and lighting and more of these simple tricks and things. And I'll see you with the Locator with software lights parts very soon. And till then, this is Swats signing off. Bye.